Hello friends, we are going to learn concept of applications of trigonometric function from the unit function and geometry and trigonometry from IBDP math, AAHL and SL syllabus, and I have taken a problem from IBDP math, AAHL and SL past paper. Now the problem here is Suleskeri and Rockall are small islands or in the Atlantic Ocean in the same time zone. On a given day, the height of water in meters at Suleskeri is modeled by the function ht equals to 1.63 sine 0.513 bracket t minus 8.0 bracket close plus 2.13, where t is the number of hours after midnight. The following graph shows the height of the water for 15 hours starting at midnight. At low tide, the height of the water is 0.5 meter. At high tide, the height of the water is 3.76 meter. All heights are given correct to 2 decimal places. A. The length of time between the first low tide and first high tide is 6 hours and m minutes. Find the value of m to the nearest integer. B. Between two consecutive high tides, determine the length of time in hours for which the height of the water is less than 1 meter. C. Find the rate of change of the height of the water when t equals to 13, giving your answer in the meters per hour. On the same day, the height of water at the second island, Rockall, is modeled by the function small h of t equals to a sine b bracket t minus c bracket close plus d, where t is the number of hours after midnight and a, b, c, d greater than 0. So it means all values are positive. The first low tide occurs at 02 hours 41 minutes when the height of the water is 0.40 meter. The first high tides occur at 9 hours 02 minutes when height of the water is 2.74 meter. D. Find the values of A, B, C and D when t equals to capital T. The height of the water at Suleskeri is the same as the height of the water at Rockall for first time. E. Find the value of t. Now the solution. So with the help of graphic calculator, we will solve this problem. New, add calculator. We will store entire function in f of x. So 1.63 sine 0.5113 x minus 8.20 plus 2.13. So your entire function will store in h of x. Now for making graph, we will insert graph and h of x we will type here. So we will be getting here graph. Now we will increase the domain. So in place of 10 we will be making 20, so you can see the high tide and low tide appropriately. Now in the question, we have to see the timing at low tide and time at high tide. So here the time is 5.138, while here the timing is 11.26. We will copy the value minus so we will be getting 6.122. So time at high tide 11.26 minus low tide 5.138, and the difference is 6.122. So 6 hours confirm. We need the value in minute in integer form. 0.122 minus 6 would be 0.122. 0.122 into 60 is equals to 7.32, and the integer value would be 7. So this is the answer of A part. Now we will proceed to B part. Between two consecutive high tides, determine the length of time in hours for which the height of the water is less than 1 meter. So we will make height of 1 meter here, and now we will find the point of intersection of 1 meter and the graph. So then the difference would be 6.707 minus 3.569. Six 6.707 minus 3.569, and the answer is 3.138. So 3 SI would be 3.14. So this is the answer of B part. Now we will proceed to C part. Hours. So this is the answer of B part. Now we will proceed to C part. Find the rate of change of the height of the water when t equals to 13, giving your answer in meters per hour. So now with the help of calculator, we will again solve this problem. Menu, calculus, numerical derivative, variable is x, value is 13, and we have the function here h of x, and the answer would be negative 0.6506, negative 0.6506. So 3 significant figure would be minus 0.651. So this is the answer of C part. Now we will proceed to D part. On the same day, the height of water at the second island, Rockall, is modeled by the function small h of t equals to a sine b bracket t minus c bracket close plus d, where t is the number of hours after midnight and a, b, c, d greater than 0. First low tide occur at 2 hours 41 minutes when the height of the water is 0.40 meter. First high tides tide occurs at 09 hours 02 minutes when the height of the water is 2.74 meter. Find the value of A, B, C and D. So here for the value of A, maximum value, which is 2.74 minus 0.4 divided by 2, so this would be 1.17. This is your amplitude. The value of D, 2.74 plus 0.4 by 2 is equals to 1.57. Now in the question, the low tide occur at 02 hour 41 minute and the high tide occur at 09 hour 02 minutes. So we will calculate the period and then we will find out the value of B. So period is equals to 2 into 9 hours 02 minutes minus 2 hour 41 minute. 2 into, so this would be 6 hours 21 minute. 2 into 6 plus 21 upon 60 . 12.7. The value of B is equals to 2 pi upon 12.7 0.495 in 3 decimal places. So your HT equation would be 1.17 sine 0.495 x minus c plus 1.57. Now we know that at 2 hour 41 minute the height is 0.4 meter. So 0.4 equals to 1.17 sine 0.495 2 plus 41 upon 60 minus, we can assume here variable x same as c plus 1.57. Now with the help of calculator, we will find out the value of x by using graph. So let us assume function gx store 1.17 sine 0.495 bracket 2 plus 41/60 minus x plus 1.57. Now we will take new graph and we will sketch the graph of gx and line of the height 0.4 and analyze intersection. So the value of t would be 5.857 and 3 significant 5.86. So now ht function would be 1.17 sine 0.495 x minus 5.86 plus 1.57. So you can see here the value of a would be 1.17, b equals to 0.495, value of c 5.86 and the value of d 1.57. So this is the answer of D part. When t equals to capital T, the height of the water at Suleskeri is same as the height of the water at Rockall for the first time. So E, find the value of capital T. So now E part, so capital H equals to small ht and we will find the value of t. So we will use calculator. H of x. Here we will use another notation, that is y x 1.17 sine 0.495 bracket x minus 5.86 plus 1.57, and here phi x, the point of intersection, first point of intersection would be so the value of t is 4.164. So 3 significant figure would be 4.16. So capital T is equals to 4.16. So this is the solution of given problem. I hope you understood this solution. Please like, share and subscribe this channel.